Thermodynamics test questions set number 2. Question 1. The properties of a system whose values depend upon mass of the system are called as A. Intensive properties, B. Extensive properties, C. Dependent properties, D. Massive properties.
Answer: extensive properties. Explanation: extensive properties depend upon mass in the system, whereas intensive properties are independent of mass of the system. Volume, energy, etc. are some of the examples of extensive properties. They are dependent upon mass of the system.
Question 2. Which law of thermodynamics is the basis of temperature measurement? A. Zeroth law of thermodynamics, B. First law of thermodynamics, C. Second law of thermodynamics, D. None of the above.
Answer: Zeroth law of thermodynamics. Explanation: when a body A is in thermal equilibrium with a body B, and also the same body A is in thermal equilibrium with a body C, then body B and body C are also in thermal equilibrium with each other. This is called as Zeroth law of thermodynamics. It is the basis of temperature measurement.
Question 3. The thermal energy reservoir from which heat is transferred to the system which works on heat engine cycle is called as A. Source, B. Sink, C. Atmosphere, D. All of the above.
Answer: source. Explanation: the thermal energy reservoir from which heat is transferred to the system which works on heat engine cycle is called as source, and the thermal energy reservoir to which heat is rejected from the system is called as sink, as shown in the diagram.
Question 4. Which among the following is our example S of sink? A. River, B. Sea, C. Atmosphere, D. All of the above.
Answer: all of the above. Explanation: sink is the thermal energy reservoir to which heat is rejected from the system which works on heat engine cycle. Heat engine utilizes the heat energy coming from the source and produces work output. But all the heat energy from the source is not converted into work, and some amount of heat energy is rejected to the thermal energy reservoir, which is called as sink. The above examples, river, sea and atmosphere, are huge enough that if some heat is rejected to them, then there will not be any considerable change in their temperatures. Therefore they are the examples of sink.
Question 5. Which among the following are the examples of mechanical energy reservoir? 1 furnace where fuel is continuously burning. 2 raised weight. 3 flywheel in running condition. 4 compressed spring. A. 1, 2 and 4. B. 1, 2 and 3. C. 1, 3 and 4. D. 2, 3 and 4.
Answer: 2, 3 and 4. Explanation: a mechanical energy reservoir is a large body which can store work as potential energy. This large body is covered by an adiabatic wall. Among the above examples, furnace cannot store work as potential energy. So furnace will not be the example of mechanical energy reservoirs. Raised weight, running flywheel and compressed spring can store the work as the potential energy.
Question 6. In the heat engine cycle, A. Work output is greater than heat input. B. Work output is less than heat input. C. Work output is equal to heat input. D. None of the above.
Answer: work output is less than heat input. Explanation: heat engine utilizes the heat energy coming from the source and produces work output. But all the heat energy from the source is not converted into work, and some amount of heat energy is rejected to the thermal energy reservoir, which is called as sink. Therefore, complete conversion of heat energy into work output is not possible. Therefore, work output is less than heat input.
Question 7. It is impossible to produce a heat engine whose sole effect is to absorb energy in the form of heat from a heat source and produce an equal amount of work. This statement is A. Kelvin-Planck statement, B. Clausius statement, C. Third law of thermodynamics, D. None of the above.
Answer: Kelvin-Planck statement. Explanation: in heat engine, net work output is always less than heat input. Hence, total heat energy transferred to the heat engine cannot be converted completely into work output. Therefore, efficiency of a heat engine is always less than 100%. Thus, it is impossible to produce a heat engine whose sole effect is to absorb energy in the form of heat from a heat source and produce an equal amount of work. This is a Kelvin-Planck statement.
Question 8. If a heat engine produces net work output by exchanging heat with only one reservoir, then the heat engine will be A. Perpetual motion machine of first kind PMM1, B. Perpetual motion machine of the second kind PMM2, C. Perpetual motion machine of third kind PMM3, D. None of the above.
Answer: perpetual motion machine of second kind PMM2.
Question 9. Which type of function the entropy is? A. A path function, B. A point function, C. Both A and B, D. None of the above.
Answer: a point function.
Question 10. The entropy is A. An intensive property, B. An extensive property, C. Both A and B, D. None of the above.
Answer: an extensive property.
Question 11. How is the entropy change of any irreversible process estimated when the process is connecting two equilibrium points A and B? A. By replacing the original process by reversible zigzag path containing reversible adiabatic followed by isothermal, then again reversible adiabatic process between the same equilibrium points A and B. B. By replacing a reversible path between the same equilibrium points A and B. C. Both A and B, D. None of the above.
Answer: by replacing a reversible path between the same equilibrium points A and B.
Question 12. Isentropic entropy S equals constant process is also A. A reversible isothermal process, B. A reversible adiabatic process, C. A reversible isobaric process, D. A reversible isochoric process.
Answer: a reversible adiabatic process.
Question 13. Carnot cycle contains two reversible adiabatic processes and A. Two reversible isentropic processes, B. Two reversible isobaric processes, C. 2 reversible isochloric processes. D. 2 reversible isothermal processes.
Answer: 2 reversible isothermal processes.
Question 14. What is the relation between the pressure change dP and volume change dV for all the real processes in nature containing pressure change dP as well as volume change dV? A. dP dV equals 0. B. dP dV greater than 0. C. dP dV 0. D. All the above options are possible.
Answer: dPdV.
Question 15. What is the dead state of the system? A. The state at which system is in pressure and temperature equilibrium with the surroundings. B. The state at which system is in chemical equilibrium with the surroundings. C. The state at which system must have zero velocity and minimum potential energy. D. All of the above.
Answer: all of the above.
Question 16. What is the exergy of a system when it is a dead state? A. 0. B. Less than 0. C. More than 0. D. Cannot say.
Answer: 0.
Question 17. Which in the examples is not a pure substance? A. Baking soda. B. Diamond. C. Seawater. D. Table salt.
Answer: seawater.
Question 18. Which is a state of the substance from which a phase change occurs without a change of pressure or temperature? A. Pure state. B. Phase state. C. Saturation state. D. Critical state.
Answer: saturation state.
Question 19. Comparing fire tube and water tube boilers. Which boiler can produce comparatively higher pressure steam than another for the same capacity? A. Fire tube boiler. B. Water tube boiler. C. Both can produce steam at same pressure for the same capacity. D. None of the above.
Answer: water tube boiler.
Question 20. What is the effect on temperature of an ideal gas when it undergoes a Joule-Kelvin expansion? A. Temperature increases. B. Temperature decreases. C. First temperature increases and then decreases enthalpically. D. No change in temperature.
Answer: no change in temperature.
Question 21. Sometimes the pump in vapor power cycle is neglected because A. The pump in not considered in efficiency of vapor power cycle. B. The pump is very small compared to the heat addition. C. The pump is very small compared to the turbine work. D. None of the above.
Answer: the pump work is very small compared to the heat addition.
Question 22. How is the capacity of vapor power plant expressed? A. In terms of heat rate. B. In terms of steam rate. C. In terms of work output. D. None of the above.
Answer: in terms of steam rate.
Question 23. What is heat rate in steam power plant? A. The rate of heat input in kJ per heat input in kW. B. The rate of heat input in kJ required to produce unit turbine work 1 kilowatt. C. The rate of heat input in kJ required to produce unit net shaft work 1 kilowatt. D. None of the above.
Answer: the rate of heat input in kJ required to produce unit net shaft work 1 kilowatt.
Question 24. What is the highlighted area enclosed by 1234 in the following TS diagram of vapor power cycle indicate? A. Heat added in cycle. B. Work produced by turbine. C. Net work produced by cycle. D. Heat rejected from cycle.
Answer: net work produced by cycle.
Question 25. To maximize the work output at turbine, the specific volume of working fluid should be: A. As small as possible. B. As large as possible. C. Constant throughout the cycle. D. None of the above.
Answer: as large as possible.
Question 26. For the same pressure ratio, what is the relation between work required to compress steam in vapor form and work required to compress steam in liquid form? A. Work required to compress steam in vapor form is equal work required to compress steam in liquid form. B. Work required to compress steam in vapor form is more than work required to compress steam in liquid form. C. Work required to compress steam in vapor form less than work required to compress steam in liquid form. D. Cannot say.
Answer: work required to compress steam in vapor form is more than work required to compress steam in liquid form.
Question 27. The purpose of study of a standard cycle is: A. To simplify the analysis of internal combustion engine. B. To increase the efficiency of internal combustion engine. C. Both A and B. D. None of the above.
Answer: to simplify the analysis of internal combustion engine.
Question 28. Otto cycle is the air standard cycle of: A. Spark ignition C engine. B. Compression ignition engine. C. Both C and C engines. D. None of the above.
Answer: spark ignition SI engine.
Question 29. How is the heat added in the Otto cycle? A. Reversibly at constant pressure. B. Irreversibly at constant pressure. C. Reversibly at constant volume. D. Irreversibly at constant volume.
Answer: reversibly at constant volume.
Question 30. What is the relation between compression ratio RK and the efficiency of the Otto cycle? A. Efficiency decreases with increase in compression ratio. B. Efficiency increases with increase in compression ratio. C. Efficiency does not affected by change in compression ratio. D. None of the above.
Answer: efficiency increases with increase in compression ratio.
Question 31. The compression ratio cannot be increased beyond certain limit because it results to A. Auto-ignition of fuel. B. Detonation. C. Engine knocking. D. All of the above.
Answer: all of the above.
Question 32. Use of gasoline blend like gasoline mixed with tetraethyl lead in internal combustion engine. A. Increases the octane rating of the fuel. B. Allows engine to operate at higher compression ratio. C. Avoids auto-ignition of fuel. D. All of the above.
Answer: all of the above.
Question 33. The ideal refrigeration cycle is like A. Carnot cycle. B. Reversed Carnot cycle. C. Rankine cycle. D. Reversed Rankine cycle.
Answer: reverse Carnot cycle.
Question 34. Which device is used for the expansion of refrigerant in vapor compression refrigeration cycle? A. Throttling valve. B. Capillary tube. C. Either throttling valve or capillary tube. D. None of the above.
Answer: either throttling valve or capillary tube.
Question 35. Wet compression is fill in the blank. A. More dangerous than the dry compression in vapor compression refrigeration system. B. Less dangerous than the dry compression in vapor compression refrigeration system. C. Equally preferable in vapor compression refrigeration system. D. Cannot say.
Answer: more dangerous than the dry compression in vapor compression refrigeration system.
Question 36. How is the condensation process in vapor compression refrigeration cycle carried out? A. At constant volume. B. At constant pressure. C. At constant enthalpy. D. All of the above.
Answer: at constant pressure.
Question 37. What is flash gas fraction? A. The mass fraction of liquid in liquid vapor mixture of refrigerant at inlet to the evaporator. B. The mass fraction of vapor in liquid vapor mixture of refrigerant at inlet to the evaporator. C. The mass of vapor actually compressed to the mass of vapor should have compressed ideally. D. None of the above.
Answer: The mass fraction of vapor in liquid-vapor mixture of refrigerant and inlet to the evaporator.
Question 38. An evaporation process of vapor compression refrigeration system. A. Heat is rejected from refrigerant to surroundings. B. Heat is rejected from surroundings to refrigerant. C. Only pressure change takes place. D. None of the above.
Answer: heat is rejected from surroundings to refrigerant.
Question 39. What is the relative humidity for a saturated air? A. 0%. B. 50%. C. 100%. D. Cannot say.
Answer: 100%.
Question 40. What is the degree of saturation? A. The ratio of the actual relative humidity to the saturated specific humidity at the same temperature. B. The ratio of the actual specific humidity to the saturated specific humidity at the same temperature. C. The ratio of the saturated specific humidity to the actual specific humidity at the same temperature. D. None of the above.
Answer: the ratio of the actual specific humidity to the saturated specific humidity at the same temperature.
Question 41. The degree of saturation varies between A. 1 to infinity. B. 0 to infinity. C. 0 to 1. D. None of the above.
Answer: 0 to 1.
Thanks for watching. Please comment, like and share.